I already started setting up the table. I'll move this back up. Okay. By our colors and the genders that we had. Okay, because it says a bicycle shop owner is trying to learn what colors of bicycles children prefer. A total of 28 blue bicycles and 56 red bicycles were purchased. So you got red bikes and blue bikes. Okay. 57 boys preferred red bikes and 8 girls preferred blue bikes. A total of 17 girls purchased bicycles. Okay, so we have some basic information there. Okay, so that's where we're starting at. So for that, what it's given us so far is that out of the bikes purchased, 57 boys purchased red bikes. So we can go ahead and put that in our table. Okay. It said 8 girls purchased blue bikes. So we can put that where the girls meet. It said 17 girls total bought bikes. So that's the total in the girls column. And it said there were 66 red bikes total and 28 blue bikes total. That's the information just that was given to us in the table. Now, as you can see, in the problem, as you can see, there's more blanks that were empty that we have to figure out what goes there. Okay, the way we do that is just some basic addition and subtraction. Okay, so when we go to do this, first of all, I'm going to get my grand total of how many bikes were all together. So I'm going to add these two together. So 66 plus 28.
94.
94 here. Okay. For the next one, I have to get this one. I've got it 2 different ways I can do it. I can either take 66 minus 57, or I can take 17 minus 8. Because either way, these two have to add to equal 66, and have to add to equal 17. So I know that's going to be 9 for that one. Okay, we're just filling in the missing ones. Now let's go on page 550. Okay, now for the blue ones, if 8 girls had blue bikes and there were 28 total, how do I find out how many boys have blue bikes?
Subtract 28 minus 8.
So there's going to be 20 boys had blue bikes. And then to get our total of the boys all together, you can either add these two together or you could subtract these. I'm just going to add these two together and get
77.
Okay. Now, if you wanted to check and make sure you subtracted or added right, you go the opposite way, either row or column, to check it. Okay. So that's all we had to do on number 17 was draw the two-way frequency distribution table and fill in the numbers. So make sure you got number 17 down. Okay. Now, for 19, it's a little bit more complicated because it wants us, we have to do our two-way frequency table first, and then it wants a relative frequency table. The relative frequency table is when we take this and then we convert it over to the percents, actual percentages for your probabilities. So number 19, we're going to have 2 steps. Okay, we have to get the table drawn first, the original table, and then we got to convert it to the relative frequencies, the percentages. Okay, so we're starting off on number 19. It says a survey was taken of 468 college-age students. So there's 468 people total, right?
Yes.
So 468 is my total. Okay, put that on there. All right. It says it was found that 83 men and 96 women were going to college. So for the men, I had 83 were going to college. For the women, I had 96 going to college. I'm just filling in the information as I read the problem. 75 women were working a job. So women, job, 75. Okay? A total of 162 people stayed at home. So home total, so that's down here in the bottom, is 162. The survey included a total of 217 men. So here's my men, so that row total is 217. So that's the information that they gave us so far just from the problem. Now we have to do like we did on 17 and finish filling in the missing blanks. Okay, so to do that again, we're doing addition and subtraction. I'm going to start here with the people in college because I have my two joint frequencies. Remember, the ones inside are called joint frequencies. What are the outside ones called?
Marginal frequencies.
Marginal frequencies, okay? So I'm going to start by just getting this total for the college students. So 83 and 96. Like that.
179.
Okay, now the other stuff I'll have to do some admin. I'm going to start here first because I have my total people all together, and then I know how many were men. So to find how many total were women, I'll just subtract. So 468 minus 217.
251.
I get 251. Now for the rest of them, you got to do like two operations. Okay. I have my total here was 468. I know my total for home, total for college. I got to find the total who worked a job. So I can add these two together and subtract it from that, or just in my calculator start with 468 and then subtract the 162 and subtract the 179. Going across there, I'm just taking my total and subtracting off the others that I had, and I get the missing one is 127. Same concept for our women row, for the one that's missing in our women row. My total women was 251. So then if I subtract how many women had a job and how many women were going to college, then it's going to give me how many women were staying at home, which was 80. And then to find these two missing ones in our men column, we can go this way. We can take our total minus the amount that were in the women, and that will tell us how many men had a job. So 127 minus 75.
52.
52.
And then for the staying at home, 162 minus 80.
82.
So 82 men were staying at home. Okay, so that was just the first part. We had to finish our two-way frequency table to be able to turn that into a frequency distribution table. So when you're doing the frequency distribution table, your main focus is how the things are related to that total down there, okay? Because remember, when we're doing the probability, it was the part out of the whole. There were 3 pairs of scissors out of the 50 items in the drawer. So on here, there are 83 men in college out of the 468 people surveyed. So when you do that is you just divide that out. So you take 83 divided by the 468. You get a decimal. We always change our decimals for our relative frequency distributions. They are percents. Now your percents, it says usually we round them to nearest 1/10. It's one place behind the decimal point. So if you look at my calculator screen, you see what we got? Okay, so is that 3 gonna make that last 7 go up, or is it gonna stay the same?
Stay the same.
Stay the same. So just remember, you gotta move your decimal point 2 places over to get the percent. So my percentage of the men surveyed that are in college is 17.7%. Okay, out of the total 468 people they asked, 17.7% are men attending college. Okay, so you take each number here and you divide it by this main total. Every single one in there. So work on doing those and filling them in. I just kind of did some scattered out so you can check and see if you're getting the same basic numbers I am on the ones that you're doing. Because some of them you had to round, some of them you don't. Everybody done? My answers look similar ones you're getting? Yes, no? I don't even see you shaking your head. You can at least shake your head.
Yeah.
Yes.
Who just went away? Who'd we lose?
Cesaria? Cesaria?
Yeah, we lost Cesaria. And Yaneli's not there. She just has her ball on the screen. She walked off. All right. Just y'all remember that's not good because your grades go down. So everybody got the idea of this, right? This was when it was just a regular relative frequency table. Okay, so everything was done by the main total. Now we also do relative frequency tables by row or by column. And that's what we're doing on number 21 and 22. One of them, it asked us to do the relative frequency by row, and then the other one asked by column. So they gave us the original frequency table though, so we don't have to do this part. They already did it for us. Now I've copied it down off the book, so I do have it up here, but you've got it there in front of you on the book as well. I just put it here so I'm not constantly trying to look back and forth as much. Now on number 21, and I just have to do it with you because the book, they actually did them backwards. On the one it said to do by row, they did by column.
Wow, that hurt.
What?
That really hurt. That big old like loud like ring.
I know.
That hurt.
It's because I have the ringer off of my phone. but since it's an iPhone and this is a MacBook, they sync up, and so it still rings on here even though my phone's off. Oh, sorry. All right. Because they're kidding. So on here, when we're doing it by row, I have to do it myself with you because the book did it backwards. It said to do it by row, but they did it by column. So see, they even mess up. Remember, rows go which way? Like this or like this? Rows go like this, right? Across. So we're doing it by row. If we're doing it by row, these numbers here at the end are our main numbers that we're using. That's our total. We're using our totals for each row to find our relative frequencies. So we're finding out how many of the teams did the raise, how many of the teams did badminton, the percentage out of the total, the 60. So what you're going to do is you're going to take 16 divided by, each one of these gets divided by 60 in this first row. So 16 divided by 60 gives me 0.26 repeating. So since it's 0.26 repeating, that's going to be 26.7%.
7.
Okay, when you're doing it by row, you use the row marginal total as your division, what you're dividing by. So 8 divided by 60, get that decimal. It's going to be 13.3 repeating, so 13.3%. And then for the obstacle course, you had 36 divided by 60, you get 3/5, which is 0.6 or 60%. And then for this one, 60 divided by 60 is 1, so this one would be 100%. When you are doing it by row, your marginal totals for your row should all end up being 100. When it asks you to do it by column, all of the column totals should end up being 100%. Okay? So that's what we're doing on there. So on this one, for the individual, we're taking 12, and this time we're dividing by 30. So 12 divided by 30 gives you 40% of the individuals did the race. 4 divided by 30 tells you
13.3.
3% did the badminton. And then 14 divided by 30 is going to be 46.7% did the obstacle course. And then anything divided by itself, remember, that one should be 100%. So remember when it says by row, you're using the row totals for each one. And then the last one, 28 divided by 90, we get 31.1%. 12 divided by 90, 13.3%. I think they like that number on that one. 50 divided by 90,
5.6.
we'll have to round up, and then this one is 100%. So when it says to do it by row, you use your marginal row totals, your marginal probability at the end of the rows as your denominator to divide by. On 22, it says to do it by column. So instead of using these totals, we're going to use the column totals across the bottom. Okay? Now, again, I drew the original one up here, but it's there for you in your book. Okay? But we're doing our totals. So these are the ones that we're going to use. These numbers here at the bottom are the ones that we're going to be dividing by. Okay? So now we're focused on like the denim. So how many wore denim how many ran the race that wore denim? How many jogged the race that wore denim? How many walked the race that wore denim? So you're doing them that way. So 18 divided by 192. I'm doing the first one, so then you can check and see that you're dividing them right. Remember what I said? If we did it by row, our row totals were 100%. We're doing it by column. So our column totals should all end up being 100%. Now, a way to check and kind of make sure you're doing them right is if I add these up, remember, they should add to equal close to 100. Now, it usually may be a little bit off because of the rounding, but it should be close. Okay? Sometimes it may be just a little bit off because of the rounding, but it should be close to the 100. So on this, for this column, you take them all and divide by 583. So is everybody finishing filling in their table? Are you doing them? Yes, no? You just waiting
Yeah.
for answers?
I'm doing them.
Oh, please, I know somebody is. So is everybody getting the idea of how this works? Yeah?
Yeah.
All right. I'll give you just another minute, fish those, and then I'm gonna go ahead and talk about the others just to make sure we get to finish going over everything, and I can talk to you about your quiz or redoing your quiz. Okay, everybody good with those? And now she comes back. Okay. All right. I want to talk about the next ones to make sure we get through them. Okay. So we're looking at number 23 and 24. It gives us a discrete probability distribution. That's what it's called when you have just the little 2-row table. It's a discrete probability distribution. Okay. On the top, it tells you that they live different X miles from church. And then the bottom number tells you what percentage fits in each category. So you have less than 2 miles, between 2 and 4 miles, between 4 and 6 miles, or more than 6 miles from the church. Okay, so on number 23, it wants to know what is the probability a member will live greater than 2 miles from church. So if it's greater than 2 miles, it's going to be, it can be between 2 and 4, between 4 and 6, or more than 6. So it's going to be these last 3 all added together. So I'm going to add 13%, 41%, and 43% all together. So when I add those together, I get what?
97.
Okay, so it's 97%. But when it's asking you probabilities from this, it doesn't want it as a percent. It wants it as a decimal. The only time it wants the percents is when it's wanting you to do the frequency distribution table with the percents of it. So I got to move my decimal point back over 2 places. So it's 0.97. It wants it as a decimal. Okay. Now, for number 24, it says, what's the probability a member will live between 2 and 6 miles? So if you're looking at the table between 2 and 6 miles, that takes the 2 and 4 miles category and the 4 and 6 miles category. So I have to combine those 2 middle ones together. So I just add the 13% with the 41% and get 54%, move it over 2 places. So it's 0.54 is the probability that they live between 2 and 6 miles from church. Okay? So that's 23 and 24. Now, for 25 and 26, it gives us a different situation. It says, find the probability of each continuous outcome. Now remember, on 23 and 24, this was called a discrete. Discrete means you can count it. Okay? On 25 and 26, it says continuous. Continuous means it has to be measured. So it says a spinner is numbered at equal intervals from 0 to 8. So I put my little numbers down here across the bottom, 0 to 8. Each value is equally likely to occur. Remember, probabilities go between 0 and 1, so that's what I have over on this side. If they're all equally likely to occur and there's 8 things, then what's your chances of one of them happening?
1 in 8.
1/8, 1 out of 8. So our little bar over here that we're going to use is 1/8. Okay. Construct a uniform distribution graph for the spinner. That's what this is called. Half of you on the quiz called it everything but a uniform distribution graph. Now, this wasn't the quiz yesterday, it was the one before. You have your book. All you had to do is look in the book. It told you what section it was. You look at the book at that section. It tells you the name of that graph. I had probability histogram. I had probability distribution table. No, this is a uniform distribution graph. Okay, had the name there for you. All right, now remember when we did these, it means if this is 1/8, so I will draw this little line down here because each of them have 1/8 of a chance of happening. Okay, now for the first one, for number 25, it wants to know the probability that the spinner is going to land between the 3 and the 6. Here's 3, here's 6. So how many sections of this graph is that? 1, 2, 3 sections of the graph, right? So I have 3 sections here times how tall was it? 1/8. So I have a 3/8 chance of it being there. Now, remember though, did we usually want our probability as a fraction?
No.
No, just talked about that up here. They want them as decimals. So 3/8 is
375.
0.75. Okay. Now for number 26, it wants to know the chance of it landing between 1 and 5. So between 1 and 5. So here's 1, here's 5. So I've got 1, 2, 3, 4 sections of the graph this time.
Four.
So I have 4 times 1/8. So that is 4/8, which is just
4/8.
half, which is just 0.5. So that's the probability for that one. Okay. So everybody got those down?
Yes, ma'am.
All right, we're almost done. Yay. All right. So For number 27, 27 and 28 says just find the probability for each of the following. So for 27, it says a 15-inch square board has a circular target on it. The radius of the outer circle of the target is 5 inches. Find the probability of hitting the target. Hitting the target. Find the probability of hitting the square board without hitting the target. Okay, I had to finish reading. I just stopped reading, sorry. I don't know what I was doing. All right, so when we go to do this, remember the target is what shape?
Square.
No.
Circle.
Target on there is a circle. The board that it's on is a square. Okay, so how do you find the area of a circle?
Pi r squared.
So I have pi r squared that goes on top. And then the area of the whole board is a square, which they already told you what it was. It was 15 inches square, wasn't it? Isn't that what they said? Or it was 15 inches.
15-inch square board.
Okay, it was 15 inches. And it's a square shape. So that's the side squared for the square. All right, I'm gonna move you so you can see where I'm at now. All right, I just make sure everybody had their other graph done. So to find our probability of hitting the target, we had the area of the circle over the area of the board. That's the probability of hitting target, okay? So area of the circle, pi times, what was the radius of the circle? I think they said 5.
Yeah.
5 squared, and then the side of the board was 15. So I have 5 squared, which is 25, pi
25.
15 squared, which is
2
2.
squared is 225.
Now, can we reduce that?
Yeah.
Yeah. Okay. 25 goes into itself 21 time. 25 goes into 225.
So 9 times.
9. So I have 1/9 pi, basically. So I got to change the 1/9 part to a decimal. What do we usually use for pi on things like this too?
3.14.
So you're going to basically take 1/9. Whoops, not 1/6. 1/9 times 3.14 and get a decimal. So it's going to be 0.349.
349.
Okay, so that's your probability of hitting your target. Now, it wants to also know the probability of hitting the square, but not the target. So that is called the what? It starts with the C.
Circumference.
No.
Don't
think geometry, think probability.
No, it's the counterpart.
Complement.
Complement. See?
Okay, it's the complement. So to find the complement, probability of not on the target, you take 1 minus the 0.34
349. Yeah.
and get
0.651.
okay. So that was number 27. Okay, everybody got that one?
Yay.
Almost done.
Moving on.
No hurry. All right. Next one. I don't know. I picked up. Okay.
Moving on.
A certain hotel offers a
Go
shuttle
on now.
student from the airport. The shuttle boards from the hotel once every 2 hours. It has a 15-minute boarding time.
Oh, wow.
Possibility that guests will randomly walk out to the shuttle during its boarding time. So it's the probability of doing in boarding time.
Yeah. Walking on boarding time.
Probability of boarding time is equal to the successful time over the total time. Over total time, okay? All right, so what we're doing is the successful time. How long is boarding time? They board for 15 minutes.
15 minutes.
Okay, now, it runs every how many hours?
2 hours.
2 hours. This is in minutes, so my total time also needs to be in 2 minutes. So how many minutes are in 2 hours?
120.
120. So it's 15 out of 120. So that's what you're going to divide to get your percentage. Whoops. So it should be
Equals 0.125.
125. Okay? Yay! All right.
All right, see you next week.
Okay. For the quiz, I have put quiz G. It's still on there till like 6 o'clock tonight or something. So I put in there where you can go back and retake it again because most of you did poo. So,
Let me spell them. Did I take it?
huh?
Did I take it?
I actually
I don't remember.
don't really remember seeing yours, I don't think.
I could have made 100, miss, but I missed 2. The last 2, miss. That's sad.
Well, you just gotta make sure you plug the stuff in the formula correctly and learn how to type it in on the calculator correctly. But it's still open, so I want everybody to go back and try it again. Everybody should at least get 5 of them right, where you just had to tell whether it was binomial or not binomial. I mean, if you missed the ones where you had to work it out, but everybody should at least get the 5 right where you're saying whether it's a binomial experiment or not. Okay? Yeah, you should get that right. Look at the ones in the book that we did together that say binomial and try to find one that sounds almost exactly the same. Because if you hadn't noticed, a lot of times the problems on the quiz are very similar to ones that we did in the book as far as the wording. So try to match those up. Try to go back and redo that, and then we'll talk more about it. I'm going to send you some stuff to make sure that you have it for your test, because I will open the test up for you to start trying to take that on Monday. But I'm going to send you a paper that has some examples and notes on there for you to use for the test. Okay? Yes? So you'll
Okay.
check My School Works probably Sunday or Monday morning to make sure that you get that so you'll have them to use for when you try to take your test. All right? Don't forget about Quiz G, trying to fix it, and then have a good weekend. I'll see you Tuesday.
All righty.